This is Chapter 8 on sampling in your research methods book. This is for research methods to statistics or applied research. Sampling is extremely important. At the end of this chapter, and the reason we're only doing one chapter this week so that we can discuss it really in detail, is the logic of probability sampling, because it makes it possible to represent a large population with small subsets of those populations. And I want you to be able to describe how probability sampling methods make it possible to select samples that will be representative of the population. You're going to see this on your midterm. I also want you to understand how our ability to estimate population parameters with sample statistics is rooted in the sampling distribution and probability theory. We're going to discuss simple random sampling. We're going to be able to distinguish the difference between the probability sampling designs, because in research we are not going to use the same sampling design for every population. Different populations and different purposes of the research will dictate what type of probability sampling design that we will use. Anyone from systematic sampling, stratified sampling, and multi-stage cluster sampling, where we'll talk about all of these in this chapter. I also want you to understand the basic features of the National Crime Victimization Survey and the British Crime Survey. These are two national crime surveys that are based on the multi-stage cluster samples that we'll talk about. You also need to be able to distinguish between the differences of the sampling types that include purposeful sampling, quota sampling, and snowball sampling. I want you to be able to describe examples of each of these types of sampling. We will do this in class on Monday. The quick and easy definition of sampling is how we collect representative data in criminal justice research. So it's the process of selecting those observations. A sampling is ordinarily used to select observations for one or two related reasons. It's because it's not possible to actually collect information from all the persons or other units we wish to study. Sometimes it is, when we talked about it in class, if you were looking at a small sample of a classroom or a treatment facility, you might be able to use all of the clients or all of the participants. But the purpose, remember, of sampling is generalization. We want to be able to generalize this over the entire population. So if that's juveniles, if that's adults, if it's females or males, we use a sample in order that represents what we are studying overall. And also it is often not necessary to collect data from all the persons or other units. It just is, it's not comprehensible in order to collect information from all the data, from all the people involved. As I said, this type of sampling, the technique called probability sampling, it allows us to make relatively few observations and then take those observations or results and generalize them to a wider population. It enables us to generalize those findings from the cases that we observe to a larger population that we don't observe. Sometimes probability sampling can't be used in some situations of interest. And one important goal that I want you to remember of sampling is to reduce, or at least to understand, the potential biases that may be at work when you are selecting your subjects for your study. I want to define exactly what probability sampling is. You need to be able to understand exactly the definition and what we're talking about. This is a method of selection in which each member of a population has a known chance or probability of being selected. So everyone in your population has as I said, an equal chance. If all members of a population are similar, there's really no need for sampling procedures. So a sample of individuals from a population, if it's to provide useful descriptions of the total population, then it must contain essentially the same variations that exist in the population. Remember, we want the sample to represent as closely as possible to the population. If you're studying a group of um, uh, children that have been abused and how it leads to later offending, if you choose a group of children that were not abused, then how are you going to generalize your results? Also, I want you to note in selecting our samples, we want to do two things. We want to select samples that represent a larger population, as I said, and we may want to generalize from a sample to an unobserved population that the sample is intended to represent. And since we are not completely homogeneous, our sample must reflect and be representative of those of the variations that exist among us. In other words, just as I said, you want your sample to represent the population in which you're studying. Conscious and unconscious sampling bias. When we talk about bias with sampling, it simply means that those selected are not typical or representative of the larger population from which they have been chosen, as I just explained in example. This kind of bias, sampling bias, is inevitable when a researcher just picks the subjects casually and doesn't use a well-formed design. Um, Personal biases may affect the sample. So if a researcher is just goes into a room and just randomly picks people and with no uniformity, then their own personal bias could be their own personal bias could result in an unrepresentative sample. And remember that probability sampling is an equal probability of selection. In other words, all the members of the population have the same chance, an equal chance of being selected in the sample. This has two advantages. Typically, it's more representative than other types of samples because it avoids bias, and we're able to estimate the accuracy or how well the sample is represented. Probability theory and sampling distribution. The theory permits inferences. Remember when we talked about inferential statistics, which we'll talk more about this next week. But probability theory allows inferences about how sampled data are distributed around the value found in a larger population. Here we've got some simple definitions. The sample element is the unit in which the information is collected, and that provides the basis for your analysis. Who or what are you studying? In this example they have here are students. The population would be the whole group, the college freshmen, if that's what we're looking at the students. And the population parameter is the value for a given variable in a population. It's an important portion of research that helps estimating the population parameters on the basis of just simply looking at those observations. Also, the sample statistic. This is a description that's summarized of a given variable in the sample. we use these statistics to make estimates or to infer the population parameters. Now, the purpose of sampling. The true purpose that we would use any sampling method is to select a set of elements or participants from a population in such a way that descriptions of those elements accurately portray the parameters of the total population. In other words, simply it's to select individuals or elements that clearly represent the population that you are studying. The key to this process is random selection, randomly selecting the participants from your identified population. That is extremely important. The sampling distribution, this is the range of sample statistics that we will collect if we select many different samples. A couple things I want to make sure that you understand before I go on is to understand really the purposes of probability sampling. It's to be as representative of the population as you can. And the larger your sample, the more confidence that we can have that it really represents the population. Also, if you have a population that is homogeneous, as I explained, meaning alike, that the more homogeneous they are, the more likely we will be able to truly represent the population. The sampling distribution in more detail includes what's called a sampling frame. Now, this is the list of the elements that are actually in our population. In other words, it's a list of, if you have a population of juniors in high school, that would be, the frame would be the list of those students in that population that you're going to choose your sample from. And when we increase the number of samples that we select, we increase the range of estimates that are provided by the sampling operation. That means that this simply means that if we have a list of elements or the list of participants that doesn't include everyone in the sample, then they can't be randomly selected, and we lose our probability sampling, and we lose our confidence that it actually represents the whole population. Sampling error. A better definition of the sampling error, it is really just if there are differences between the characteristics of a sample and the characteristics of the population, then that increases our sampling error. So a sampling error is really just the differences between the characteristics from the sample to the population. So the larger the sampling error, that means that the sample is less representative of the population. So obviously we're looking for a low sampling error, which is measured with the standard error, which we're not going to get into exactly how to do that. You just need to understand what sampling error is. If you've got a high sampling error after you do your statistics, then you will know that your sample is not a true representative of the population. So what does all this mean? What does sampling error mean? What is this probability of representing the parameters of the population and blah, blah, blah? What is all this? Simply what we're trying to do, remember we talked about external validity. We talked about generalizing the results to the population. If our sample does not represent the population, then our threat of external validity goes up. And therefore we can't generalize our findings to the population if the sample doesn't represent the population. That's all that really means. A sample needs to represent the population as closely as possible. Now, how do we measure sampling error? I will talk about this a lot more in class, but this has to do with confidence intervals. Now, confidence intervals is really just a level, it's a level of confidence, a specific interval or distance that our statistics fall. So let's say, for instance, I put in a 95% confidence interval into my statistics. And let's see, it's not going to make a lot of sense, but let's say I'm looking at an R statistic. And for my R statistic to really be significant, it needs to fall as close between 0 and 1, as close to 1 as possible. That just means that it's more accurate. So, and it's more significant. Well, what'll happen is when we talked the other day about our p-values, the confidence interval actually takes the place of our p-values. So for instance, if I say I want to know the level of confidence around my result, so it might say that it might give me the result of the value between gosh, it's hard to explain. What we want when we get a result of our confidence intervals, we want it to be within 10. That means 0.10 between those two numbers. So you might get a number of 0.82 is the low and 0.98 is the high of the interval. Well, that means that our sampling error, that's not an accurate representative. So that one would not be significant. What I've done here for you is I have pulled up my dissertation because I used confidence intervals. So I want to show you, and maybe this will help you understand exactly what they are. Here's the definition. A 95% confidence interval around the effect sizes and mean effect sizes were computed. In other words, what that means is I used a 95% confidence interval around the statistic that I used. And in this case, I used R. So, but a confidence interval should be less than 0.10 in width, and that means from the smallest number to the biggest number. Shouldn't be any more than 0.10. That means it's a precise estimate of the true parameter. In other words, it's representing what it should be. If the intervals overlap, and this is among variables, that this indicates that the effects are not significantly different. And if you listen, this is all jumble, mumble, blah, blah, blah. But if the 0 value is not included in the interval, then the result is statistically significant. So, makes no sense, right? Okay, let's go down here and look at an example, and I will show you the effect sizes. Okay, here we go. These are the confidence interval. I'm sorry. This is the confidence interval. So right here, the result of right here, negative 0.09, that's my R value. Oops. That's my R value. That's my statistic. That's my result. That's what I got when I did my computations, okay? This number falls in between this number right here, okay? So it is telling me with 95% confidence, because this number might be off a little bit. You know, it's never, remember, they're all estimates. But it's saying that with a 95% confidence, it falls between negative 0.15 and negative 0.02. Now, that number right there is a difference of 13.13. And you ignore the negatives, okay? It's a difference of 0.13. That did not fall within my 0.10 interval that I said I needed for it to be precise and correct. it's not far away, but it's still, I have to go somewhere where it's my, where it's my cutoff. This one right here is way off. It's from -19 to 14. So that means that my estimate is just really not precise at all. Let's see, let's find one that is. Okay, right here. Now, oh, that's not going to help me. That's the overall. Okay, right here. What this is saying is that this value falls between -0.11 to -0.03, right? Now, if you subtract -11, -0.03 from -11, you get what? -0.08. That is less than 0.10. So therefore, it's telling me that I'm pretty sure with a 95% confidence that this is the number. So when I look at this, I can say that the recidivism measure that I used here, that this is how recidivism was measured. It was measured by arrests or charged. I can be pretty confident that it increased, that this number is correct. That's what the confidence interval is telling me. I will bring this to class and we can go over more of this. Okay, let me get out of this. Oops, yep. Okay, let's move to the next one. This is really just summing up, and of course it says it at the top, of what I just said. So you have random selection, which permits the researcher to link whatever findings they have from their sample to the body of the parameter. I'm sorry, that's not what it's saying, but it allows us to link what we find in the sample to our population. It allows us to generalize. And as I was going over, I talked about the confidence interval and the confidence level. It just means that when you're doing your research and you're using the confidence level, the confidence interval, you have to specify those. You have to tell in your research what your level is. So what's normally accepted is the 95% confidence interval. You can do a 90. You can even do a 99, but obviously if you do a 99, it means you're going to have probably less results because it's a smaller percentage. Or if you go with the 95%, which is the same thing we talked about with a p value of 0.05, that still is saying the same thing. That we're saying that with a 95% confidence, we know that this sample represents the population. And as I stated last week, and that the result is not from something outside of our relationship. So if we are examining offenders and recidivism, and we get a high, say we get a confidence interval that falls in that 0.10 and does not overlap and is within and we use a good 95% confidence interval, we can say with 95% certainty that the type of offender did increase recidivism. Whatever our variables are, we're saying that one does cause the other, they are related, they're associated with each other, there's some significance there. We found something good. This information is just stating the same thing that we just talked about. That, remember when I was telling you earlier, we're going to go over the different types of probability sampling designs. So you can use one or a combination of this is how you pick your sample. And the key feature of all probability sampling designs is that relationship between your population and your sampling frame. Remember, the sampling frame is the list of elements from which your probability sample is selected. So this is saying that that samples that are drawn correctly and through a type of sampling design that are designed properly, They provide information that's appropriate for describing the population that we got our sample from. That's it. Simple random sampling. This is considered the foundation of unbiased sampling. And as I said, the simple random sampling is the easiest. It's the simplest. It just means that every element within your sample is given a number. So say you've got 100 offenders. So every offender gets a number 1 to 100. Then you take those numbers, put them in a hat, and just draw out as many as you want. This can also be done in a computer program. So it's just it's like a lottery procedure. It's just each number has the same amount of probability to be chosen. That's what simple random sampling is. Next, we talk about systematic sampling. This is just an extension of the simple, in that maybe you get a sign of how you're going to pick your numbers. So if you have 10,000 elements or 10,000 offenders, and we only want to pull out 1,000, we might select every 10th element or every 10th offender. So if we have them even on a list of 1 through 100, we might select, every 5th one all the way through. So it's just a systematic way of choosing them. Now there is the danger right here that we need to talk about, because if you think about it, how were those initial numbers assigned? So it depends on how you arrange your elements on a list. So you just need to decide how they get their numbers ahead of time. And also in stratified sampling, this is a more efficient way than just drawing a simple random sample. For instance, we get the word strata, and it means that maybe there's different stratas within our population. For instance, maybe a neighborhood has a population of 15% African American, 10% Hispanic, 5% Asian, and 70% Caucasian. If you do a simple random sampling, so all of those have the same amount of value, to same equality to be involved in the sample, then you might end up with all that are Caucasian. Therefore, it's not a true representative of the sample. So if you create your sampling strata based on race and ethnicity in this example, then you can select cases from each stratum. So you would want a percentage from each strata. Does that make sense? Okay. We can talk about it more Monday. If you have questions, make sure you write them down. Next, we're going to talk about multi-stage cluster sampling. This type of sampling is a little bit more difficult, but sometimes, as we talked about our sampling frame, sometimes it's not possible to have a list of all of the population. For instance, the example they have here is the law enforcement officers. To get a list of all law enforcement officers in the U.S. and then try to do a sample from all of that would be next to impossible. So this type of sampling involves 2 steps. Well, first you identify your cluster, which could be, let's say, police officers in, maybe you pick cities. So we'll say police officers in Knoxville, Nashville, and Memphis. So those are our different clusters. After you have your clusters, then as a researcher, we would choose from each cluster a random sample. And this is where we talked about before, you could have a couple different types of sampling designs. So if you use your multi-stage cluster sampling, and you have, which is something that Kyle would actually use in his, because he's looking at different school systems, possibly. So if you those would be his clusters, and so from each school he would choose a sample, and he might use random sampling, he might use a stratified sampling. So here we've combined 2 different types. The next two discussions on the National Crime Victimization Survey and the British Crime Survey, these are examples of the sampling we just talked about. Now, the National Crime Victimization seeks to go into all households within the United States. So it's impossible to get a list of all the households in the United States. So the sampling frame that would be used, first we would use the multi-stage sampling. Sorry for the interruption. I think I was saying the example that we're looking at is the National Crime Victimization Survey. That is an example of the multi-stage sampling process, where um, the cluster sampling, because what they did first was define the primary sampling units, what they called PSUs. There were 93 large self-representing strata. So those were all included. And then all of the other smaller ones, or ones that had a lower density or that had a variable that they were looking for. So there was 150 strata to choose from. They chose from them proportionally. So for instance, if one of the strata was 1% of the total population they identified, then that strata would only have 1% of the number that they chose. Does that make sense? Okay. The other one is the British Crime Survey. This was also, the multi-stage cluster sampling was also used for this survey. So they derived their sample through different stages. So they stratified by geographic area and population density, and then they chose from those strata according to the amount within those strata, just so that they wanted to represent the population that they were looking for. And that's really simply what that means. Is you want, again, remember we were talking that we want our sample to represent the population that we have chosen. And so if your population, remember, if it's more homogeneous and everybody's more alike, so if you were looking for an income, for instance, and you chose an area where the incomes were relatively similar, and that's what you were studying, then you could choose just from that population. But if you were choosing, let's say, an area where you had a number of different incomes, where you might have anywhere from 10,000 to a million, so you want to put those in certain strata and then choose from each strata so that it fully represents what you're looking for. Now, we're going to talk just a little bit about non-probability sampling. And remember that probability sampling means that everyone in the population has an equal chance of being in that sample. So non-probability sampling is the opposite, where the probability that an element will be included in the sample is not known. So you cannot generalize your results to a larger population. So in those instances where it's impossible to use that probability sample, then you would use non-probability sampling. There are 4 types of non-probability sampling that we are going to discuss. They are purposive sample, quota sampling, snowball sampling, and the reliance on available subjects. To begin with, purposive sampling is selecting a sample on the basis of your judgment and for the purposes of your study. This is a very common type of non-probability sampling. For instance, let's say you wanted to study car thieves. It's not really possible to get a list of all the car thieves in the country because some aren't reported, aren't caught. We don't know. I mean, there's a number of different reasons. So so we need to choose a group or a population that is visible that we know of. So we might go to a prison and only choose those that were charged or sentenced on cars, on car thievery. The next is quota sampling. This type of non-probability sampling actually is similar to probability sampling, where you are selecting your sample from the population that you want your sample to have the same characteristics that exist in your total population. So you begin, as you do in probability sampling, you begin with a table or a list of the characteristics of the population that you are wanting to study. And then from that, you take a percentage of all of those different cells so that they make up the population that you're trying to study. Now, there are some problems with this in that the quota frame must be accurate. You know, your sampling frame has to be accurate that describes the population. So for instance, let's say you have a population that's, I'm going to do a very simple one, 10% blue houses, 60% red houses, and 30% black houses. So on those, you want an equal represented from all of those. So in each sample, you're going to take 10% of that sample of those 10, and then what did I say, 60% of the next house type of house, and then the 30% of the last house. So, but if you don't identify the characteristics correctly, what if you chose a white house that's white and black and put it in the white house, or I say red house, or if you chose a house that wasn't where it went, then you would have your bias and it would mess it up. And also, too, you might have a bias in just the simple selection of the elements within any given cell. How do you pick those samples from that strata that you picked? So you might have a bias by the way that you pick it. These are just things you have to be aware of. The next one is the reliance on available subjects. This means that you are conducting a study because you can get the subjects. So in other words, I'm studying homeless people. So I'm just going to walk around an area and find all the homeless people. They're available because they're right there in front of me. Also, too, remember we mentioned a good one about how many people run a stop sign. So you might sit on a corner, and so the only subjects that are going to be in your non-probability sampling design are going to be those that drive by that stop sign. So you are reliant on the subjects that are available to you. Now, the last one is snowball sampling. And this is actually can be used in a population that is hard to get access to. For instance, or untrusting. Say you wanted to do prostitutes. So you might interview a prostitute and then ask them for somebody else. Can you tell me of another prostitute that might talk to me? That's snowball sampling. You just go from one to the other to the other. And that's all I have for Chapter 8. I'm sorry, I know some of it may be a little confusing, so we will go over this a lot more in class. I want you to be prepared and come to class having listened to this, as well as have read on these type of samplings, because I want you to be able to give me examples of the types of sampling that I just went over.